Professor Dave here. I'm going to tell you about elemental analysis.
He knows a lot about the science stuff. Professor Dave explains.
Let's say we have an unknown hydrocarbon. That's a molecule consisting of just hydrogen and carbon. Let's also say we want to know the empirical formula of the hydrocarbon, or the lowest whole number ratio of carbon to hydrogen atoms in the molecule. Is it 1 to 2, 1 to 3, 3 to 5? A while back, we figured out a clever way to decipher this ratio. When we combust hydrocarbons, that is, burn them in the presence of oxygen, we get carbon dioxide and water as products. So all of the carbon in the hydrocarbon ends up in carbon dioxide molecules, and all of the hydrogen ends up in water molecules. We developed this nifty apparatus whereby a sample of hydrocarbon with known mass is placed here over the flame. The tube is open to allow oxygen to enter, and then the vaporized products travel this way through these materials. One material absorbs water, the other absorbs carbon dioxide. We weigh these materials before and after the experiment, and the difference will be the mass of water and carbon dioxide absorbed respectively. So, let's say we have a sample of benzene, but we have no idea what the ratio of carbon to hydrogen is. We burn a 0.342 gram sample, and we collect 1.156 grams of CO2 in here. Since CO2 weighs 44 atomic mass units and a carbon atom weighs 12, each molecule of CO2 is 27.3% carbon by mass. That means in the CO2 there are 0.316 grams of carbon. So of the original sample of hydrocarbon, this much of it must have been carbon, and the remainder must have been hydrogen. That makes the hydrocarbon 92.4% carbon and 7.6% hydrogen by mass. We call that the percent composition of benzene. Let's go a step further and find the empirical formula. If we pretend we have 100 grams of the hydrocarbon, 92.4 grams would be carbon and 7.6 grams would be hydrogen. Using their atomic masses to convert to moles, we get roughly 7.6 moles of each, which indicates a 1-to-1 ratio. Therefore, the empirical formula of benzene is CH. This means that there is the same number of carbon atoms as hydrogen atoms in the molecule. If we want to find the molecular formula, which is the actual number of atoms of each element in a molecule, we need the molecular mass. Let's say we know that for benzene the molecular mass is 78. 1 unit of the empirical formula weighs 13, and 78 divided by 13 is 6. This means we need 6 units of the empirical formula to get the molecular formula, or C6H6. Let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials, and as always, feel free to email me, ProfessorDaveExplains@gmail.com.